All right, folks, here we are on remote calculus for some notes. Find the general antiderivative of. This is going to help you out with homework set number 2 with the antiderivatives. Okay, so here's the initial function. F of x is 2/3 x to the 4th minus 1/3 x to the 3rd plus 2/5 x squared plus 3/4 x, or x to the 1st, minus 2/3. It was just minus 2/3. We were making a previous video. Had a phone call come in here. So just minus 2/3 for the time being. And it was just x, but you can put x to the 1st in. All right, so the power rule for antiderivatives, again, given f of x, I'm going to find capital F of x. Capital F of x is the antiderivative. F prime of x is the derivative. So instead of bringing down the power and having one power less, I'm going to raise the power up one and divide by the new power again. So instead of bringing it down and multiplying, I'm going to raise it up and divide. Opposite. So I'm going to add 1 to this power. It's not going to be x to the 5th. I'm going to divide by 5. Minus 1/3. I'm going to add 1 to that exponent 4, and I'm going to divide by 4. Plus 2/5. I'm going to add 1 to the exponent 3 and divide by 3. Plus, I'm going to add 1 to this exponent. It was x to the 1st, now it's 2. I'm going to divide by 2. Minus, this was really x to the 0. So if I add 1 to it, it's x to the 1st. I'm going to divide by 1, and then plus that constant. All right, 3 times 5 is 15, minus 1/3 times 1/4 is 1/12, plus 2/5 times 1/3 is 2 over 15 again, plus 3/4 times 1/2 is 3/8, minus 2/3, x plus c. All right, number 2 here, I take the derivative of, again, here's what I had initially. I take the derivative of cosine to get negative sign. So if I want positive sign, I'm asking myself, what? I take the derivative of what to get positive sign? Positive sign, it would be the derivative of negative cosine. So the antiderivative, you don't know the symbol yet, the antiderivative of sine is negative cosine. All right, so negative 8 cosine x plus c. Again, we need that arbitrary constant there. So on 3, I take the derivative of what to get cosine? If I take the derivative of sine, I get cosine. That means the this is an integral sign. Antiderivative of cosine is sine. So it's going to be 12 sine 2x. Again, I'm doing like the chain rule in reverse here. So if I were taking the derivative of this, I would multiply by 2. If I'm taking the antiderivative, I'm going to divide by 2, this right here, or multiply by half. Okay, I'm doing the opposite. If I was taking the derivative of this, you know, it would be, let's say I was taking the derivative of this, it would be 12 cosine 2x. Then I would take the derivative of 2x, which would be 2. So taking the antiderivative, instead of multiplying by 2, I would multiply by half. 1/2, 12 is 6, sine 2x. Again, if I take the derivative of this, it would be 6 cosine 2x times the derivative of 2x, which is 2. Derivative of a constant is 0. And I get back to that. All right, so number 4, let's take a look here. The negative 1/3 sine 2x. Again, if I take the derivative of cosine, I get negative sine. So the antiderivative of negative 1/3 sine would be positive 1/3 cosine. 2x, again, the antiderivative. Think about the opposites of a derivative, like the rule here. Again, don't take the antiderivative, then you're left with x squared. If I were taking the derivative of 2x, I would multiply by 2. And say with the antiderivative, I'm going to multiply by 1/2. 1/3 times 1/2 is a 6, cosine 2x plus c. If I took the derivative of this, it would be negative 1/6 sine 2x. I would multiply by 2. That's how I would get that. The derivative of a constant is 0. Number 5, 2 over 3x minus 4 over x squared plus 5/6. All right, I'm going to rewrite this as 2/3 times 1 over x minus 4 times x to the negative 2nd plus 5 over 6. I'm going to take the so I just need to know, the derivative of natural log is 1 over x. So the antiderivative of 1 over x is natural log. So know that. Antiderivative of 1 over x. So the integral 1 over x dx. I've shown you what the antiderivative is. Natural log x plus c. write those out later. Then 1 power up, I add 1 to negative 2, that's negative 1, and then I divide by negative 1. Again, what I add to any constant is an x plus c. A negative divided by negative is a positive. X to the negative first means over x. There we go. On 6, 4 times 3 minus x, all of it squared. I'm going to FOIL this. 9 minus 6x plus x squared, distribute. Then it's simply the power rule. So add an x to a constant. Add 1 to the power 2, divide by 2. Add 1 to the power 2, 3, divide by 3. And just simplify that, plus that arbitrary constant c. And let's keep going. Number 7 here. F of x is 8 minus 4x plus 5x squared divided by x squared. I'm dividing everything by x squared, subtracting 2 from the exponent. 8x to the negative second. Now, I'm not writing this as minus 4x to the negative first, because if I try to take that antiderivative, 1 power up would be x to the 0, and then I would divide by 0. That's not okay. I need to write it as minus 4 over x. Then plus 5, x squared divided by x squared. All right, so we need to think about minus 4 over x as a minus 4 times 1 over x. The antiderivative of 1 over x is natural log, just attached to negative 4. Add 1 to the power, negative 1, divide by that power. 8 over negative 1 is a negative 8. X to the negative first puts x in the denominator. Minus 4 natural log x plus 5x plus c. And number 8. I take the derivative of what to get cosine? I take the derivative of sine. So the antiderivative of cosine is positive sine. So for sine x, I take the derivative of what to get secant tangent? I take the derivative of secant to get secant tangent. So the antiderivative of a negative 10 secant tangent would be a negative 10 secant x, and then plus c, my arbitrary constant. F of x is equal to the 4th root of x to the 3rd minus the cubed root of x plus the 5th root of x squared. I'm going to rewrite these. This is from Algebra 2. Go from radical to radical form to exponential form there. Fractional exponents. X to the 3/4 minus x to the 1/3 plus x to the 2/5. Add 1 to the power, that's 7/4. Instead of dividing by 7/4, I'm going to multiply by the reciprocal 4 over 7 minus. I'm going to add 1 to the exponent, that's 4/3. Instead of dividing by 4/3, I'm going to multiply by 3/4, the reciprocal plus. Add 1 here, or 5 over 5, that's 7/5. Instead of dividing by 7/5, I'm going to multiply by 5/7, the reciprocal. And what I believe is the last page in this notes video, number 10 here. So the antiderivative and the derivative of e to the x is e to the x. So in taking the antiderivative, it would be 4e to the 3x. And again, if I were taking the derivative of this, I would multiply by 3, because that's the derivative of 3x. So when I'm taking the antiderivative, I'm going to divide by 3 or multiply by 1/3. Again, if I take the derivative of this, it would be 4/3 e to the 3x times 3. Again, the derivative of c is 0, the constant. And that is what I was given it initially. All right, so it's the same thing here in 11. Antiderivative of 5e to the 2x would be 5e to the 2x, and instead of multiplying by 2, which is the derivative of 2x, I would multiply by half, plus 4, 1 power up, x to the 4th, divided by the new power 4, plus c, 5 over 2, e to the 2x, plus the 4's cancels, x to the 4th plus c. And f of x is 8 minus x over x squared. I'm going to divide both of these by x squared. That's going to be 8x to the negative second minus 1 over x. The antiderivative of 1 over x is natural log x, so minus natural log x plus c, 1 power up, 8x to the negative first divided by the new power. We've seen that a lot. 8 divided by negative 1 is a negative 8. X to the negative first, that goes south, minus natural log x plus c. 4 over x minus 1/3 e to the 2x. Again, 4 over x is 4 times 1 over x. The antiderivative of 1 over x is natural log x. minus 1/3 e to the 2x. Instead of multiplying by 2, I'd multiply by half. 1/3 times 1/2 is 1/6. For natural log x minus the 6 e to the 2x plus c. Next video up would be the antiderivatives quiz number 1 review video. This is the Math video signing out.